For decades, we've been using the same method to launch rockets into orbit. We simply strap a lot of fuel to the rocket and let combustion do the heavy lifting for us. But this new California-based company plans to change that. Meet Spin Launch. A California-based private aerospace company wants to throw rockets into space. Yes, you heard that right. Just simply throw rockets into space. This is the fascinating story of an emerging tech company that might change how we put satellites into orbit for the better. How does Spin Launch work? Spin Launch was working more or less under the radar until their first successful launch test back in October. This was the company's first test. Spin Launch launched a passive projectile from their suborbital accelerator. According to the company, the projectile reached tens of thousands of feet high. So, how does the whole plan work? Well, the concept is pretty simple. Spin Launch is developing a mass accelerator that will be used to spin a rocket around and around and let it gain kinetic energy. When the projectile has gained enough kinetic energy, the accelerator will let go of the rocket. Since the rocket still has all that kinetic energy, it will keep its momentum and gain altitude. While Spin Launch has proposed this rocket to be a clever alternative to chemical rockets that need to burn lots of fuel and use the ejecting mass to fly, Spin Launch still needs help from the combusting chemicals. This is because the kinetic energy alone from the Spin Launch won't be enough to put it into low Earth orbit. So, the company's orbital launch system will throw the rockets toward the sky at a speed of 8,000 kilometers per hour or 5,000 miles per hour. When the rocket reaches a height of about 61,000 meters or about 200,000 feet, the rocket will ignite its engines to give it the final boost it needs to get into orbit. According to Spin Launch, after the engines are ignited, the rocket can reach a speed of 28,200 kilometers per hour or about 17,500 miles per hour. Think of it like this. Imagine you tie a rock at the end of the string and then start spinning that string around you. When you let go of your string, that rock will speed away in that direction the rock was facing when it was let go. Spin Launch is doing that, but on a huge scale. All the spinning for the rocket happens inside a closed accelerator. The company calls it the suborbital accelerator. This suborbital accelerator is about 50 meters tall, just about the height of the Statue of Liberty. Inside the accelerator, a giant arm spins the rocket around. The rocket is attached at one end of this arm. The accelerator maintains a complete vacuum inside the chamber during launch. This is to eliminate air friction that will cause unnecessary energy loss. Spin Launch wants to make sure that the rocket is spun as fast as physically possible to give it the maximum kinetic energy. When the rocket has been spun to the required kinetic energy, it is released through a tube and into the air. In the test footage, you'll notice that it bursts through some sort of cloth or cover. This is basically a seal to maintain the vacuum inside the centrifuge chamber. According to Spin Launch, their launch vehicle will be able to withstand the colossal pressure difference once it is released from the accelerator, because it would essentially be hitting a wall of air when it exits the centrifuge coming from a total vacuum environment. According to their FAQ page, they have designed their rockets to survive the high temperature. Once in the air, the rocket will ignite its engines to cover the last leg of the journey to orbit. There is something very elegant about an idea that is very simple yet solves a very complex problem. There are obviously people that are skeptical of the idea, but like any innovative idea, only the future can tell if it is viable or not. According to Spin Launch, their accelerator was only working at 20% of its full power capacity for their live launch back in October. And the current suborbital prototype is only 1/3 of the size of the actual accelerator that they will develop for commercial use. It will be called the Orbital Launch System. It will be using the same technologies that they are currently testing on the suborbital accelerator. Why the need to throw rockets? So, in a world of SpaceX and Blue Origins, why is Spin Launch hurtling rockets into space? The main reason Spin Launch thinks this idea will catch on because it's very fuel efficient and clean. A major portion of any launch vehicle's weight is fuel. A rocket needs a lot of fuel to be burned to gain the acceleration and momentum to reach orbit. Spin Launch wants to get around that by throwing the rocket into space instead, and using a chemical engine for the last leg of the journey instead of using it for the whole journey. And the idea does make sense on paper. It is more environmentally friendly, considering you only need a huge motor and electricity to power most of the rocket's journey. Yes, we know just because something uses electricity doesn't mean it's clean. Our major sources of electricity still rely on fossil fuels, but switching to electric means of propulsion means that everything will be in place once we finally reach a place where most of our energy comes from alternative energy sources. According to Spin Launch, this will be cheaper as well. Since a lot of the fuel cost will be eliminated, they estimated that their orbital launch system will require 4 times less fuel and will cost about 20 times less as compared to a conventional rocket, putting the price of a single launch just under $500,000. Not only will it be cheaper for existing customers to launch satellites into orbit, but with such a low barrier of entry, it will become much easier and cheaper for smaller companies to launch their satellites. This will make satellites much more accessible for smaller to medium-sized companies. Spin Launch claims that they will be able to deliver 200 kilograms or about 440 pounds of payload per launch. This dwarfs in comparison to SpaceX's main payload delivery rocket, the Falcon 9. It can do about 22,800 kilograms or 50,000 pounds, but Falcon 9 is orders of magnitude more expensive to launch with an average cost per launch of about $57 million. Currently, smaller companies have to piggyback their payloads onto launches of larger companies because they can't afford a launch of their own. Small rocket companies like Rocket Lab are already working on making smaller and affordable rockets. Spin Launch will be competing with Rocket Lab for smaller companies looking to do affordable launches of their satellites. About the company. Jonathan Yanni founded Spin Launch in 2014 in Sunnyvale, California. Currently, the company is headquartered in Long Beach, California. It has raised about $110 million in funding from investors like Kleiner Perkins, Google Ventures, and Airbus Ventures, etc. So a lot of big names are backing this project. While the October test rocket didn't have an engine inside, in future tests we might see engines. According to Yanni, Spin Launch plans to conduct 30 more tests over the next 6 to 8 months, so we might be hearing a lot from Spin Launch in the future. The company was pretty much under the radar and very secretive before its first launch in October. According to Yanni, this was on purpose. In a statement to CNBC, Yanni said, "I find that the more audacious and crazy the project is, the better off you are just working on it, rather than being out there talking about it. We had to prove to ourselves that we can actually pull this off." According to Yanni, Spin Launch will be establishing a proper launch site. Currently, they are testing from Spaceport America in New Mexico. Virgin Galactic also operates from this spaceport. According to Spin Launch, they are looking for coastal locations for their first launching facility, and that site needs to be able to handle a dozen launches per day. The concept behind Spin Launch is simple yet genius, but the plan is not without its risks. Only the coming years will tell if Spin Launch becomes a success or dies down as one of the many novel ideas that never gained commercial success.